How's everybody doing today? Pretty good? Awesome. So my name is Kenneth Reitz. You can follow me on Twitter at Kenneth Reitz. And I work for this company called Heroku, which is pretty awesome. And we do web application hosting, basically. So if you'd like to talk to me about that later, you can. We're also hiring people. And we love documentation. We have another guy here from the documentation team, the Dev Center team it's called. So come and talk to us. But, can you hear me now? All right. Could you hear anything I said before? All right, cool. So if you know who I am, it's probably from the work that I've done in the open source community. I have everything up on github.com/KennethReitz. And if you go there, you'll find about 18 serious projects and 100 little experiments that are useless. The most popular of which are, there's OSX GCC installer, which people use to install GCC on their Mac without having to install Xcode, which saves them a lot of trouble. It's been down 56 terabytes of downloads of that so far, which is pretty awesome. And requests has been downloaded 3 million times, which we're going to get to in a minute. So I'm a software developer, engineer, obviously, and I have all these other passions as well that I like to spend my time with other than code. So I'm a street photographer. I get to travel all over the world for work and speaking at conferences like this, and I always try to take pictures wherever I go. I like to mess around with synthesizers and make music, and I play a lot of like old video games and like I have a Game Boy, a DS. I play on the planes and stuff like that. It's pretty fun. And I've noticed like over the years I've kind of assembled this list of my favorite things that I have, and I found a trend between all of them. So for photography, I always end up using prime lenses instead of zoom lenses. A prime lens basically is a fixed focal length, so you are basically set in the frame that you're going to be taking the picture in, and you can't adjust it without moving your feet or actually interacting with the environment that you're in. It's a very simple way of looking at things. And so for synthesizers, I find that I like monophonic synthesizers. Usually they have a pretty simple architecture that can only play one sound at a time, but it allows you to really focus on that sound and be pretty creative with it. Same goes with a bunch of other stuff, pen and paper. With all the travel I do, I try to only bring one carry-on and not have like a bunch of luggage I'm lugging around. It's a lot of things I see amateur travelers carrying like 7 bags with them all the time. So all these things really are basically constraints. And constraints really foster creativity, I've found. So, if I'm using prime lenses and monophonic synths and handheld games and stuff like that, geez, sorry. That might happen a lot. I never actually hit play. That was an accident. Anyway, all of these things are constraints that really allow you to focus on the problem that you have at hand. So, I just want to take notes. I don't need this ultimate, web device that does all this stuff and takes notes and does transcription and audio. I just want to take notes. So I'm going to focus on having a pen and paper, and I can just do the thing that I'm trying to do. Or if I'm using a prime lens, I'm basically forced to be good at composure and actually take good photos, as opposed to getting lost in the gear. So I really think of this as like a pragmatic approach, and I try to take this approach with all the things I do, from code to documentation to everything. Pragmatic means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. Basically, it's really easy for people to try to get some device that will fit every single use case that they could ever have, and it becomes a bit of a problem. You see this with code that people write. People will try to build frameworks that will work for any situation. And what will happen is if you try to build something that works for everybody's use case, it'll often harm the thing that you're trying to do. And it'll make those 90% of people that want to use your thing have a bad experience. So my project here, Requests, this is a Python library for HTTP, is the big example that I use for this. This is what I like to call a pragmatic package for Python. Basically, it's really hard to send HTTP requests in Python by default, because the things that are built into Python for doing this are built around this idea of solving every use case imaginable, as opposed to, let's make 90% of the people that are going to use it, and let's make their lives really easy. So I went through and I made this project, and it's been really successful, and people really like it. And I think that the success of it is 100% a result of the API. And I like to say that the API is all that matters, and everything else is secondary. And what I mean by that is that basically, when it comes to a package like this, when you're working with code a lot, the thing that made this package popular isn't that it was fast or that it was secure or all these other things. It was all because of the API and because people liked the API. And it's a really good approach, I think, for a lot of different projects. So there was this set of tapes that were uncovered recently. They're called like the Lost Steve Jobs tapes or something ridiculous. And there's this great quote I found inside of them. So this is Steve Jobs in 1983 talking about the Apple computer. It was very early on. They weren't the hottest people around at the time. And what he said was that people are going to be spending 2 or 3 hours a day with these machines, with these computers that they were building. Yeah, right? Well, that makes this even more important. It's more time than they spend with their car. So software design should be given at least as much consideration as we give automobiles today, if not a whole lot more. And I think this is really true because, like you think, everyone laughed, right? We all spend like 12 plus hours a day on our computers. And automobiles, they spend millions and millions of dollars on R&D and research and development and, on design. And they make the whole car out of clay before they actually bring it to the manufacturing process. That's amazing, the amount of detail that they put into this and research. But we don't do that with software. Some people do. And I think there should be more of that, treating it as a real craft. So Apple, I think this kind of informs all their decisions that they make, is this idea of real craftsmanship in the things that they're building. And I think it's really worked out well for them. People really like all the Apple products. They like the industrial design of all the MacBooks and all, and the iPod and the iPhone. And the software generally has it's more aesthetically pleasing than a lot of other systems. And that really paid off for them. So, this isn't just necessarily for user software. I think this really applies to APIs as well if you're a software developer. Developers are going to be spending over 8 hours a day working with your APIs, so that you should be putting at least that much effort into your APIs as well. So requests, basically, I think HTTP should be very trivial, very simple. And so what I did was I explored. I was frustrated trying to use HTTP all the time. And so I discovered what I needed, and then I decided to build the tool so I could use it. And then I didn't even expect anybody to use this thing at all. But I solved a real problem for myself, and it turns out there's a lot of people that were just like me. So at first, it kind of sucked, but more people got involved, and it started to get more popular. And the features grew over time, and the API was never compromised. So how do you do this? If you want to repeat this process, how do you go about and try to make an API that actually works really well for your use case and your users? And for me, I think it all starts with writing the docs. Thanks. Basically, here we go. So before you write any code at all, for this, let's say you're going to write a library that's going to solve some problem you have. I like to start with writing the README, when basically I show some code examples of how I'm going to be using this code before a single line of it is written. And that really allows you to you write some theoretical code with this code that you're documenting. So you actually all right, if I'm going to write an HTTP library, I'm going to hit the GitHub API, and here's what it would look like. That same little clip of code that I showed you for requests at the beginning there, that color-coded thing. That was basically in a README before I wrote any code, and that's kind of what I was always shooting for. And that worked really well. So instead of engineering something then that's kind of just self-serving and trying to, you're building little blocks that fit together, and at the end it kind of isn't the best thing in the world, but it's functional, you start to really interact with the problem at hand when you start to write the documentation like this first. And you build an interface that reacts to the problem. So I like to call this, basically, you're discovering the problem and you're responding to it. So great sculptures aren't necessarily manufactured or engineered. Someone doesn't go out and try to find, they don't just pump them out in a factory somewhere. Basically, a sculptor studies a piece of marble and he listens to it, and then he releases the sculpture that was hidden inside all along. And I feel like problem solving can be considered the same thing. So responsive design, is anyone here not know what responsive design is? I think it's right, cool. Basically, you're trying to build something that will work on a phone, it'll work on a tablet, on the desktop, on any device. And that's what most people can think of responsive design as. But really, I think it's something deeper than that. I think it's making something that identifies enough with itself to be able to respond in the environment that it's placed in. So basically, it makes it free of arbitrary constraints, and ideally, your code or your page, whatever it is that you're working with, that you're trying to make responsive, understands enough about itself that it will just present itself properly, which is a good goal. I feel like this approach to building APIs is like responsive API design. Basically, you're dropping the code right into the problem before you actually have any code written, and you can forget all the technical debt and all these other things that often burden code and make it worse. So I think we can all agree that complex code is bad. If you work, well, you'll see a lot of large code bases that end up happening. There's a lot of tight coupling, a lot of things that are touching each other that shouldn't be. You have a lurking and growing technical debt that starts to spread throughout the code base. The larger the code base, the harder it is to maintain code. It becomes tremendously more difficult to maintain extremely large pieces of software as opposed to small ones. And it makes the code self-serving instead of problem-solving. So the antithesis to this is that simple code is awesome, basically. It's very complicated. Code solves problems that are created by humans, and generally humans are fairly simple creatures. It's pretty easy for us to understand what the actual problem is, instead of like just having a bunch of code that's serving its own purpose. So the less code you have, the less work it is to maintain all of it. If you do a lot of open source work, the best pull requests, in my opinion, are pull requests that remove lines of code, not add lines of code, or remove functionality. And kind of this concept of small, sharp, and distributed services that all interact with each other as opposed to one giant code base that's difficult to maintain. So this is a great quote by the founder, I think, of the ZeroMQ company. There's a company behind it. And I love it. It's basically that simplicity is always better than functionality. And I try to apply that to all the stuff I do. So who here uses open source? Awesome. There's a lot of different definitions for open source. You have like, free as in beer, free as in speech. You have free as in freedom. There's all these different definitions, but the one I want to focus on today is that basically I think open source are transparent groups of distributed developers working together to make software and projects and the world a better place to live in, basically. And that it's not always the case, but I think that's a nice kind of package to put all the open source developers in. Open source is like actually pretty amazing when you think about it. Basically, like we really have this unique opportunity right now, if you're working in open source or with it, to take part in a powerful social movement that's creating tools that are fundamentally changing the world around us. If you look at things like social media, you have like Facebook and Instagram, all these things that everyone's talking about. You have Twitter. These things are like on the news, and they're like informing opinions, starting revolutions. All these things are built on open source tools. They're built on the things that open source developers build. And that's incredible. Elections, if you look like immediately after they announced like who the next president was going to be, they're like, now let's go look at the tweets, and that's all like open source at work, really. I think that's amazing. Journalism, like WikiLeaks, is obviously very controversial, and that's all based around open source tools. Open source is amazing. And I feel like documentation is the glue that makes this whole ecosystem possible. So if you look, there's both good and bad sides to open source. I apologize if anyone in here maintains any of the projects that I have listed. If I'm wrong, you can yell at me later. So there's some really bad open source projects, and when I say bad, I mean normally they're badly maintained. Often you'll go to a GitHub repo that of a project that you want to use, and you'll see like 20 plus pull requests and 138 issues. And the last push was 2 years ago. That's a huge problem. It happens quite a bit. And another big problem in open source is that someone will build something and it doesn't really solve a clear problem. It'll be very abstract and theoretical, and it's not a very pragmatic approach. Some of the best projects can come out of that, but if you go to a page and you don't know what this project is trying to solve, it's going to be hard to know how to use it. And the third key mistake of a lot of bad open source is they have unclear expectations. People don't know why this project was created, why it's being maintained, what are the motives of the developer. In the case of like the Facebook SDK, there was this Python Facebook SDK basically that was on GitHub, and it like stopped working like 4 years ago or something. And then there was this issue that someone opened up about like, hey, maybe you can give us an update on what's going on here, and had like 39 comments from different people. And the response to it was they just like turned off issues completely. So you can see that was the response, which is a terrible way to do things. So it had unclear expectations, and well, they made it very clear what their expectations were when they did that. So I have some examples here of really great open source projects. And so I have Jenkins, Python, Django, pip, bundler, a lot of tools like that. And I feel like all of these tools solve a very clear problem. It's very obvious what they do when you go to their pages and when you try to get involved. And basically this comes down to they all communicate well with their users and their other developers. And that allows people to manage expectations realistically. So when you go to like a Django page, they're going to see all the different releases and what the maintenance expectations are and how to get involved. There's documentation on all of these things. And all of these things are documentation. So who here has worked with a company with terrible internal code base? It's a very recurring problem. It's kind of all the same things that that monolithic code base that I was talking about earlier. Basically, when you're working at a company and you're working on a project, people have a huge tendency to start building really large code bases, and the components get really tightly coupled. Or even if they're little separate things, they're often very coupled. And it requires a lot of broad tribal knowledge, usually. So if you're going to go work on a project, you might have to study up on it for a week or keep bothering some guy across the cubicle from you. Trying to figure out what this weird thing does because there's no documentation, right? Iterative change of components can become difficult when you have a large code base like that, and technical debt can spread really, really easily. So one little part, that has this weird thing that was shimmied together because it's an internal project, you have a deadline, you have to make the managers happy, leads to a terrible code base when it's the whole thing's in one code base. And all these things are results of having terrible documentation, in my opinion. But we'll get there. So what I like to do when I'm working on an internal project is I like to pretend that it's an open source project. And I feel like this constraint really fosters some really good behavior on my end, and I think it helps with a lot of things. Basically, when you're building an open source project, if you're going to build something and you're going to assume that other people are going to be consuming it, you're going to try to make that thing general purpose, make it decoupled, make it very concise, solve a single problem, make its purpose clear. A lot of best practices start to emerge. So if you're like, say you're going to make some kind of like a project like read the doc, sorry, and you're going to have that up on GitHub. You're not going to have your database credentials in the repository, but people do that all the time internally. So if you just pretend it's open source, like these things, all these best practices kind of automatically are forced upon you. Basically an open source project is completely useless if it doesn't have any documentation. And the same goes for your internal code. So if you pretend it's open source, you'll be writing documentation from the beginning, and that makes the world a better place. And of course, if you do want to release the code at open source at any time, you can just flip the switch if you build it this way, which is always a nice benefit. So document everything. I feel like documentation really leads to better code. Documentation to me is better than tests. So say I'm working on internal, open source, anything like that. There's test-driven development, which teaches you to make things more composable over time. So there's some different things you need to abstract out. It makes it so you have this pattern and you're encouraged to build more composable projects. Documentation, for me, trumps that completely because it really helps me make more consistent APIs. It changes the way that you think about problems. And explaining concepts to users and fellow developers helps uncover asymmetry in APIs. So what do I mean by asymmetry? It's kind of a weird thing to hear about with APIs. So I'm going to use a Python example. I know everyone in here isn't Python, but it should be kind of clear. So Python 2.5 came out like a decade ago. People use it for some reason still. So there's two different basic string types in Python. You have byte strings and Unicode strings. A byte string is basically what's written on disk, and a Unicode string is kind of this imaginary perfect text object that we all have in our brains that doesn't fit into disk. You have to encode it into bytes. So there's two different syntaxes for this. If you have a string, you just put the quotes for a regular byte string in Python 2.5. And if you want a Unicode, you put a U before it, and that marks it as a Unicode string. So when Python 3 came out, basically everyone was using byte strings instead of Unicode strings all the time. This is a big problem. So they're like, all right, we're going to make Unicode the basic type. So if you have no special marker, just a regular string there with the 42 in the bottom, it's just going to be Unicode now instead of bytes. And then if you want a byte string, you put a B in front of it. So Python 2.6 came out. They're like, all right, well, we want to make this backwards compatible. So because they were maintaining two of these at the same time. So they added bytes for Python 3. So if you have a byte string in 3.1 and you run it in 2.7, it's there. But then if you were to write documentation on this and explain it, it took them years to figure this out. It would be pretty obvious right away, because I'm explaining it right now, and there's obviously something that's not matching up there, right? Because these things, they just switched, and suddenly there's a hole. And it took 3 years, and then eventually we got this Unicode thing, which ended up being one of the most controversial additions to the language in years. It was 500 messages on the mailing list about it. But there you go. They added the Unicode one that's back there, so now all these things match up, and there's no syntax errors if you have one from the other. And now it's a symmetrical API. And I think if you're explaining this to people and you're writing documentation about it, as opposed to just sticking into the code and focusing on the problems, if you're focusing on the users, these things become immediately obvious when you're writing a lot of documentation. So documentation makes for a better code. I feel like it also leads to a better workplace. Every design decision within your company, within your team, within the people that you work with, maybe even your personal life, all these things should be documented. Not your personal life. Basically this reduces process locks and synchronous points, so it kind of fosters distributed development styles and the open source methodology into the workplace. You can automate the onboarding process. If someone needs to figure out, I want to work on X, Y, or Z, they don't have to go and tap someone on the shoulder. This stuff is documented. They don't have to worry about being wrong because there's a document that is canonical that people reference for this problem. So employees can hop from project to project if they need to. They can deploy to production without worrying if they did something wrong because it's documented. And I think this is the first step towards automation. Ideally, everything would be automated, and if you wanted to deploy to production, you just type a command and it happens. And I feel like that can't really happen until you document. So imagine never having to tap on a coworker's shoulder again, and imagine never getting interrupted by a coworker again. Wouldn't that be amazing? We can dream. Documentation also leads to a better lifestyle, because documentation enables asynchronous workflows, increased autonomy leads to a happier life, and fewer misunderstandings, fewer interruptions, less war, I don't know. It depends on how far you take it. So documentation clearly makes the world a better place. So write the docs, or the sloth will find you. That's it. Thank you. Do we have time for any questions or not? Yes.
You just talked about documentation as something that developers do.
Yeah.
At least, especially API documentation. Is there any role in API documentation for people who are not developers, professional tech writers?
That's a good question. So as a writer or as a consumer, I guess.
As a writer, does if a developer, okay, you just talked about yourself sitting down and specking out your API before you even start coding it. Mm-hmm. Is that the final form of the API documentation, or does someone else come along and say, well, wait a minute, Ken, that doesn't make sense?
I feel like that's kind of like the starting point. So usually for a serious project, you have something that's called a README, and then you have the actual documentation. Right. And the README is just kind of this 10,000-foot view. Here's how you use this thing and how you install it. And then the real documentation is a very in-depth, guide, and often has a lot of prose in it. And I think that if you're a technical writer, you could be really useful at helping form that. Especially if if you're someone who's not a developer and you're reading this stuff, it should be very obvious to you where things are missing. Because if you're familiar with the code base and you're working with it all the time, some things might seem obvious to you that to someone who's not technical might not seem obvious at all.
I guess the reason I'm asking this question is I've worked in a lot of situations where they follow the model that you just described, where API documentation is something the developers do. Mm-hmm. And the culture that seems to develop around this is that the developers say, we own the documentation, we're not going to let those technically illiterate tech writers near it.
I feel like really great docs are more than just API reference. So there's some that are just literally like, here's all the different methods and classes and functions, and here's how to use them. And I feel like really great documentation has a lot of pros to it. And I feel like technical writers could be very useful for that. The Python community in particular has a lot of pros in their documentation, which is great. So the more the merrier, I guess.
Any more questions? Yeah? Okay, great. And folks upstairs, you can ask questions too. We'll run the mic up to you.
Thank you. I'm curious, when you talk about documenting all the things, how would you reconcile that need with an agile environment where you're told explicitly to value working software over documentation? Are you able to speak to that?
For me, I feel like I have a really bad habit of writing documentation after I write code, and I always find that when I'm writing it as I write the code, my code gets tremendously better. So I feel like even if you're in an agile environment, you can still do it iteratively. You don't have to write this perfect document with all of this, this hierarchical information architecture and things like that into it. You don't have to have this perfect document. You can have something that's kind of a work in progress. And I feel like if you're writing the docs as you go, it'll save you time in the long run because things will become more obvious that weren't before, like those asynchronous APIs, ideally. But, there's always trade-offs.
Any more questions? Questions? Oh, I see a hand up there. Here we go.
It's like parkour. So I'm just really curious, as an open source maintainer, are there any, what do you do to encourage people to be able to contribute to documentation? Like when it comes to codes, there are certain standards. You wouldn't change someone's code stylistically and put out a pull request, and but when it comes to documentation, maybe they use the word preferences 8 times in a sentence, and you see a way to fix that. How do you make it easy for users to know what that social contract looks like, and what's helpful and what's not, and what do you find helpful?
So on my projects, I have a code style guide, actually, or a documentation style guide, usually. It's not that involved. Mostly it's like, try to break things up, and be concise, basically. And I find that projects like Read the Docs, sorry. I'm going to be doing this all day. Read the Docs, I think, helps tremendously. So I'll have like a workflow in my documentation. And I say, if you want to change something, just send a pull request. And the second I hit the merge button, and usually if it's related only to the docs, I'll almost always merge it, because normally if someone's going to be changing them, they're doing something good as opposed to writing something terrible. It's just kind of a pattern I've noticed. With code, people will add terrible code, but it's a lot harder to write terrible English, I guess, basically. I'm just going to leave. Yeah. So having read the docs is great, because then I merge it and it's on the site instantly, and they see instant feedback. They don't have to wait for me to release the next version of the library, and I think that's super helpful. And if they did something that I don't approve of, someone else wants to change, someone else can just send a pull request, or I can update it. It takes 2 minutes. And it's easier than refactoring a bunch of code. So, yeah.
All right. Thanks so much, Kenneth.
All right. Thank you very much.